As we have seen various color types in the previous video, now we shall input these color types at Bisco and explore further settings. You can download the corresponding files from the link mentioned in the description. From the File menu, choose Open Bitmap and select the bitmap downloaded. Then the bitmap loads into Bisco. For this example we use a simplified wooden window frame with 2 cavities. The glazing is replaced with a standardized insulation panel, as per EN ISO 10077. We know that our frame is 0.1 meters, so we input the width to color 20 as 0.1, and you notice that the entire bitmap is scaled proportionately. Now we will customize the properties at Colors window. First, we will try to manually input the properties, and later we'll see how to directly input from the color database or standards. We will name the color 7 as an insulation panel with a conductivity of 0.035, the color 20 as wood with a conductivity of 0.13, for cavities we have colors 33 and 65, and we consider simplified radiation for them. Hence change the type to Equimat by double-clicking, and now it has an equivalent thermal conductivity which considers conduction, convection and radiation. Physical flow direction represents heat flow direction in reality, either horizontally, up or down. The geometrical heat flow direction corresponds to the heat flow direction in relation to the bitmap orientation. This parameter is updated automatically during calculation. We notice that we can't change the physical heat flow direction here, as they are linked to standard EN 10077 which assumes horizontal heat flow. However, if we change the standard we are free to customize these parameters. Nihil here means the values are not linked to any standards and all parameters are free to customize. Under subtype we can choose from cavity, which is non-ventilated, or cavity E, which is for slightly ventilated. As per EN ISO 100772, when the opening of the cavities exposed to the external or internal environment is less than 2 mm, then we consider that cavities are non-ventilated and choose the subtype cavity. Whereas if the cavity opening is less than 10 mm, then we consider that it is slightly ventilated and choose subtype cavity E. In our case we choose cavity as neither of them are connected to the exterior nor interior environment. We will name the cavities as cavity 1 and cavity 2. To restrain infrared radiation through low E coating, for example, we can reduce the surface emissivity of one side of the cavity to 0.01. Similarly, you can do the same for another cavity. You now notice equivalent conductivity also significantly reducing. Next, for color 74, we change the type to BC Simple, and under the subtype choose HE, which represents exterior conditions. In the status bar at the bottom, you always can read the description when you hover the cursor on any option. For color 94, we change the type to BC Simple, and under the subtype choose HI Normal, which represents interior conditions. For color 134, change the type to BC Simple, and under subtype choose HI Reduced, as we need to input reduced surface coefficient at interior corners, as per EN ISO 10077. You can refer to the standard for further details about this reduced heat transfer coefficient. Now we can click on the Calculate system to run the analysis. At the graphic output, if we turn on the fill temperature, we can visualize the result. Later we will explore further at the graphic output window. Now you can close the graphic output window. At the Colors menu, by default it's under List Present, which means only colors defined to the geometry are shown in the Colors menu. If we choose to list all 256 colors will be displayed, out of which few have predefined properties representing a material, cavity or boundary condition, whereas few are empty, allowing us to input our customized properties, like how we did for this exercise. The colors which we use to input the geometry in this file are in white in editable format, and the rest of the colors are in yellow. If we choose the list defined, only the colors with predefined properties are displayed and the colors with empty parameters are not shown. Now change back to the list present. You can also download the color database as a document and keep it handy. You can download it from Physibel website, under the knowledge base. Here you can type color as a keyword and you find the document here. If you want to input the color from the color database, Choose the color you want to change, then from the bitmap menu choose to change color. Now you can input the color number you want to change. Upon clicking OK, you see that color window updates with the properties of the new color. Any changes we make to color properties at the color window are locally made and won't affect your future projects. If you want to change the default color properties which will affect all the subsequent projects, from the File menu choose Open Color Database. Bisco asks you if you want to save the current file as Bisco application will close to open Bisco Color Database file. Here you can notice all the list of 256 colors in an editable format, and any change you make here will change the default color database. You can now close this window. Thank you for watching. See you at the next video.